Hello everyone, again welcome to my channel. So we have already uploaded two videos on complex analysis, part 1 and part 2. If you have not seen that, kindly go to the description section and kindly see that. Then you give a necessary comment. So in one of the comment, one of the student or maybe one of the faculty has asked me to do some presentation on differential calculus. Now differential calculus is a very huge topic. So if I want to discuss, it will take a lot of classes. So today's class, let me just discuss some of the very important thing which is called derivative and absolute value. So we know that for engineering, science or for any other background, derivative is a very must concept. So today's class we try to know what is derivative and what is absolute value and what is their relation, or how we can find the derivative of a absolute value function. Okay, so let's start. So let me take a function y equals to fx. When we say derivative, it means dy dx or f dash x. Now what does that mean? Again I will go back to geometry. So I have taken one curve y equals to fx, then I am taking one point on x axis a and a nearby point on x axis x. So this distance is a and this distance is x. So corresponding to a, the functional value will be f of a, because it is y equals to f of x, so the functional value will be f of a, and for this point the functional value will be f of x. So now these 2 points, though I have drawn it in a bigger manner, but you can visualize that these 2 points are very close to each other. Okay, so let this point is a, this point is say b. So what will be the coordinate of a? The coordinate will be a comma f of a, and what will be the coordinate of b? It should be x comma f of x. So what we have done, again I am repeating, we have taken a simple curve y equals to fx, it may be any curve, then we have taken two nearby points, that is the distance is almost 0, though we have drawn it a bigger manner, and we just explain that what will be the ordinate and abscissa of that one. So the first point is a comma fx, second point is x comma fx. Now point A, this is A and FA, point B, this is X and Fx. Now if I take, carefully you see what I am taking, if I am taking the change in the function, that is the second coordinate, divided by the first coordinate. So fx minus fa divided by x minus a, this is the rate of change of output with respect to rate of change of input. What does that mean? That means when we have given the input as a, the output is f of a, and when we have given the input as x, the output is f of x. So that is the thing. And if we have taken limit x tends to a, what does that mean? X tends to a, so if I just draw this again, so this is the situation, this is a, this is x. X tends to a means this point will tends to this point along the curve. So what does that mean? This means this ratio and limit x tends to a means the derivative of fx at a, and it is denoted by f dash a. Okay, so this is the basic derivative definition which we know already. And one more thing, when x is tending to a, that means the b point is coming closer to a point. So basically when b will be coming closer to a point, so this will geometrically represent tangent at a point. So the geometrical meaning of derivative is tangent at that point. So what we have got? The definition of derivative: limit x tends to a, fx minus fa divided by x minus a. This is actually f dash a. Okay. So this is the derivative part. Now we know many formula of derivative, like ddx of what will be ddx of x to the power n, that will be n times x to the power n minus 1, ddx of e power x, that will be e power x, ddx of sin x, that will be cos x, and so on. So I will not go into that formula because already you know this formula from your book or from any other sources. So what is my intention is that I want to explain the definition. Okay. Now let us go to some other topic, which is absolute value. So absolute value. So it is generally denoted like this: mod of x. We are familiar with this symbol. What is the meaning of mod of x? If you give 5, it will give you 5. If you give minus 5, it will again give you 5. That is, this is like a machine which will make every number positive. So if you give some positive number, it will be positive. If you give some negative number, then also it will produce the positive value. So the definition is, this is x if x greater than equals to 0, and this is minus x if x less than 0. This is the mod function. Now first question we want to encounter in this lecture, that what is the derivative of mod x at x equals to 0. So we want to find the derivative of this function as x equals to 0. Now you look into some fact. See, we have chosen carefully the point x equals to 0. Why? Because 0 is the changing point. Because the function is, if it is more than 0, it will be x. If it is less than 0, it will be minus x. And if it is equals to 0, it will be 0 only. So carefully we have chosen the boundary point or the turning point. And again one more thing, when one function representation will be like this, like 2 or 3 expression will be there depending on the condition, then you be sure that you have to apply the definition, not the formula. You have to apply the definition. So here also we try to find the derivative of mod of x by the definition. So limit x tends to 0 plus, what does that mean? See, this is the 0 point. You can go to 0 from left hand side or from right hand side. From any side you can reach to 0. Now when I am writing x tends to 0, that means I can reach x to 0 either from the right hand side of 0 or from the left hand side of 0. So if I am approaching from the right hand side of 0, then it is 0 plus. If I am approaching from the left hand side of 0, then it should be 0 minus. And if the both limit will be same, then only the derivative will exist, because then only the limit will exist. So if I go this limit x tends to 0 plus, the definition is fx minus f of a means 0 here, divided by x minus 0. So what is that? Limit x tends to 0 plus. Now when it is more than 0, 0 plus means more than 0, that is bigger than 0, then the value is x. So fx will be x, f of 0 will be 0 divided by x, so the value will be 1, because x by x 1. Again, if I take limit x tends to 0 minus fx minus f0 divided by x minus 0, then it will be limit x tends to 0 minus. Now 0 minus means we are going from the left hand side of 0, so it should be minus x, minus 0 by x, so it should be minus 1. Now we have seen that the two values are not same, so limit does not exist, hence mod x is not differentiable at 0. So I think this is okay, and this we have encountered from class 11 or from class 12, because whenever we read any definition, modulus, derivative, we are getting this kind of situation. Okay, so this problem is a common problem which I have done. Now we want to go for the higher version of modulus. Let's see. Now in this problem I am going to tell you something. Please carefully listen and try to follow the same pattern for all the modulus problem. Then any problem will be easier if you want to consider any modulus. Okay, so problem number 2. Now the function is given x minus 1, and we have to check if this one is differentiable or not. Now carefully listen. Now there is not a single modulus, now there are two modulus and the addition is there. Now how to perform this? You can't simply write that this is differentiable or not differentiable without checking. So first of all you have to check that. Okay, so if I go for the solution, what will be the first thing? You see this one, if you solve this one, you get x equals to minus 2. If you solve this one, you get x equals to 1. I think you can understand that. X plus 2 equals to 0, so x equals to minus 2. X minus 1 equals to 0, so x equals to 1. So what will be your first job? You draw a number line, put this value minus 2 and 1. Understand? So first of all you have to put this modulus value where the modulus will be 0. Okay. So now you see this is the whole number line. The number line is divided into 3 parts. This is part 1, part 2, part 3. That means one part is x less than equals to minus 2. One part will be x will be more than minus 2 but less than 1. So minus 2, and another part will be x greater than 1. So this is basically part 1, this is part 2, this is part 3. Okay, so for all the modulus problem you have to first divide the number line into this pattern. This is very important. Now what will be x plus 2? Modulus, if it is mod x, suppose if it is mod x, a single quantity, so it should be x plus 2 if x plus 2 greater than equals to 0, and it will be minus of x plus 2 if x plus 2 is less than 0. So basically it will be x plus 2 if x greater than equals to minus 2 and minus of x plus 2 if x less than minus 2. Understand? So now look into this one. So if x less than minus 2, so in this portion it will be minus of x plus 2, and when x greater than equals to, in this portion it will be x plus 2. Okay. Similarly, for the second function x minus 1, it will be x minus 1 if x minus 1 greater than equals to 0, and minus of x minus 1 if x minus 1 less than 0. So basically we have got x minus 1 if x greater than equals to 1 and minus of x minus 1 if x less than 1. So if x greater than equals to 1, so from this portion it is x minus 1 and from this portion it is minus of x minus 1. So I think first you can observe this. So what we have done, first we divide the number line into 3 parts. How? Because we have done the solution and this point will be the divider point. Next we write the individual mod function and we have seen that what is the nature of this one. Okay, so now the number line is becoming a bit clumsy, so let me write in a fresh manner. So now basically we have got this situation. Okay, let me draw in this side. We have got this situation. There is minus 2, there is 1. This is the number line. Now here less than minus 2, then this will be minus x plus 2. When greater than, this will be x plus 2. Here also it will be x plus 2. Okay. For the second function, so first function is okay. For the second function, when less than 1, so it should be x minus 1. It should be again minus x minus 1. So basically we have got this situation. And when greater than equals to 1, it should be x minus 1. So this is the thing. Now you see, the whole number line is divided into 3 parts. In all the parts, say part 1, part 2, part 3, we have got the functional value. Okay. So what will be the final function? So fx was mod of x minus 2, x plus 2 plus mod of x minus 1. Now what will be the thing? Fx will be, first of all it will be x less than 2. Less than equals to 2, minus 2, sorry. Then it should be summation of this one, minus x plus 2 minus x minus 1. Then it should be in this region, so minus 2 less than x less than equals to 1 or less than 1 you can write. It should be minus x minus 1 plus x minus 2. X plus 2, and finally it will be x greater than 1, that is the right hand side, it should be x minus 1 plus x plus 2. Okay, so finally we have got the function. So what is the final version of the function? Fx will be minus x, so minus 2x minus 2 plus 1, so minus 1. If x less than equals to minus 2, and it should be x and x will be cancelled out, so it should be 3 if minus 2 less than x less than equals to 1, and it should be 2x plus 1 if x greater than 1. Okay, so this is the thing which you need to understand. So again I am drawing this one, this is minus 2, this is 1. So less than minus 2, the function is minus 2x minus 1. Between this, the function is 3, this it is 2x plus 1. So now look into the problem. Initially some modulus function was given to us. Now we have changed the modulus function and we have got individual function without mod. So that is very important. Now what is the basic problem? The problem is you have to check whether the function is differentiable or not. Now you carefully listen this one. Only you have to check to the boundary point. If the function is differentiable to the boundary point or the joining point, then the function will be differentiable. So only it is sufficient to check at minus 2 and 1. So first check at for x equals to minus 2. So then it should be limit x tends to minus 2 plus it will be fx minus f of minus 2 divided by x plus 2. So it should be limit x tends to minus 2 plus. Minus 2 plus means 3 minus f of minus 2 means if you put here it should be again 3 divided by x plus 2, so it should be 0, and limit x tends to minus 2 minus f of x minus f of minus 2 divided by x plus 2. So it should be limit x tends to minus 2 minus 2 minus, that means we are going from the left hand side of minus 2, so fx should be minus 2x minus 1 minus f of minus 2 will be 3 divided by x plus 2. Okay, so if you just simplify you get minus 2x minus 4, so if you just divide it should be minus 2. So now we have seen that the left hand side limit of minus 2 is minus 2 and the right hand side limit is 0, which are not same. So the function is not differentiable at x equals to minus 2. Okay, now let us go for x equals to 1. For x equals to 1, again the same logic, limit x tending to 1 minus, it should be fx minus f of 1 divided by x minus 1. So limit x tending to 1 minus. Now 1 minus means we are going from the left hand side of 1, so the value is 3 minus f of 1 means 3 divided by x minus 1, so it should be 0, and limit x tending to 1 plus f of x minus f of 1 divided by x minus 1. So limit x tending to 1 plus. Now when we are going from 1 plus, that means we are going for the right hand side. So it should be 2x plus 1 minus 3, because f of 1 is 3 divided by x minus 1. So if you just see that it will be 2x minus 2. So if you take 2 common, it will be x minus 1, it will be cancelled out, so it should be 2. So here also we have seen the left hand side value is 0, the right hand side value is 2, they are not same, hence it is not differentiable. So today's class, what we have learned? We have learned the basic definition of differentiability, which you know from your school level. Then we have seen that normal differentiation formula we know, there is no use of formula in this case. So we have carefully chosen some modulus function, because modulus function is a very favorite topic for any competitive exam or for any kind of hard exam you can say. So you have to understand the nature of modulus function. So initially we have done mod x, then we have done a bigger problem. So please follow this and try to do this step on your own. Don't just mug up and don't just see the video and just think that you can do. You please do it on your own, and if any problem is there, you can mention me in the comment section. Thank you for the video, and by the way, please like, share, subscribe, and please press the bell icon for getting all updates. Thank you.